Very well. My name is Damián, and I'm going to talk about the AI GeneXus module. I'll try to be short because I'm sure you're tired. The AI module is something I presented last year, and it's going to allow us to work with building blocks. What do I mean by building blocks? It's like small pieces that are common or frequent that AI uses, such as image recognition to recognize something, to detect faces, scenes, text. We could also do some audio, video processing, natural language, translation, and so on. So let's look at this. This is the overview of the GeneXus AI module. Now, this module is installed. I mean, if you browse GeneXus Toolbox, you can go to Manager and Knowledge Manager, and you'll have all the modules that you may create, among which GeneXus AI. And you click Install in your KB, and under References, you'll have the GeneXus AI with the module. So we have one for audio treatment, images, video, and so on. We're going to see it in detail later on. Later on means now. This is what the AI module offers in terms of video. It will allow us to get in touch with in the cloud and see. You see here every operation per module. Under audio, we can do speech to text and text to speech. That is to transform audio on the basis of text and vice versa. We can certify images. We have OCR, optical character recognition, which will allow us to extract text on the basis of images. Under text, we have detect languages, extract entities, extract key phrases, analyze sentiments. This means on the basis of the opinion of a user, you may decide whether that opinion is positive or negative. Then we have the classic translation systems, and video analyzes us to analyze video. You're going to process it, and then on the basis of the analysis, you'll see whether well, it refers to many characteristics. If you watch a video, it's a sequence of frames, and you add to that some audio, you'll have the two characteristics of the first two modules in the video module. Then if you look at the columns, you'll see the providers, those based in the cloud. The ticks are marking the facilities available. And then the last two columns are on devices for mobile devices. I'm sorry, he corrects himself. The first one is Alibaba, which is a Chinese provider, Amazon, Baidu, Google, IBM, Microsoft, SAP, and Tencent, that it's another Chinese. On device, instead of doing it from the cloud, they do it from their own mobile devices. We're working on those operations so that they can be available soon instead of making a request to the cloud provider. If you have any questions, please, you can interrupt me. Any questions? What's the mobile requirement? To be able to run the NL in an iPhone. Well, I don't have this very clear, particularly for Core ML. I know it runs on the basis of iOS 12. I think that the rest depends on the type of device. It's not very clear. I don't know that very well. Once it's really analyzed, it has to do with the hardware. Well, once this information is published, we'll have it in our public wiki. So let me go on. Another important module in the hierarchy of GeneXus AI is in the one you can configure the provider. You'll have an SDT with this aspect where you'll be able to select a name, you'll select a type of provider, and this is based on a number dominion listed on the that we've seen on in the previous transparency, and you can probably see other types of properties according to your own needs. Now, how would we use GeneXus AI? Well, the first thing would be to complete or put information in this provider. You put a name. In this case, I chose Google, and you would charge. You would upload the properties there. In this case, we have classify. We're going to put an image, the provider we've just configured, and then we'll have in return a collection of labels, which is the classification it made on the image that we gave at the beginning, and a collection of images where you get information about whether there was a mistake or there's a warning or anything. It's recommendable that once you complete the operation, you have to check that this collection is empty. If it's not empty, you'll be able to manage it. If our image is this one, we'll put it in GeneXus AI, and this module will give us something like this. We are saying that the entry is a butterfly, and Google provider will say it's an insect with a certain probability, and it's going to give us, with a certain level of confidence, it's going to give us several labels on the basis of what you've seen. If tomorrow you don't agree or you don't like what Google has given you as a result, then you simply have to change the configuration of the provider, and that's it. You won't change anything else. If we wanted to change, and for Microsoft, we would change those properties and the properties associated to that provider, and that'd be it. What I'd like to share with you now, because what happens is that providers in the cloud would offer that, if we take the example of the classify, they offer labels by default that are quite generic. So when you go to an image, butterfly, for example, it says it's an insect or an animal, but doesn't say it's a butterfly. Of course, that depends on the provider, but it may happen that it doesn't say it's a butterfly. Now, in that case, it doesn't fit into our needs, into our business needs. Therefore, we'd like to be able to train a personalized model that tells us that that image was a butterfly and make it more particular and not so generic. Now, the model flow is just this one. I don't see if you can see it well from the end, but let me tell you about it. This is a possible flow to train a personalized model, customized model. The first stage is to make a data acquisition. You'll be able to collect data so that our mechanism, our AI, can learn on that basis from them and then make reference on other data. There are two large stages. The first one has to do with data collection and data labeling. For instance, one thing would be to gather images of butterflies and perhaps another type of insect and say that these images correspond to a butterfly and the other images correspond to other categories. A second stage would be the creation and training of the model. The first instance, then, we have training. Training is a very complex stage in AI because it involves lots of mathematics, configuration, parametrics. If you know or heard about neuronal networks, you have to say what algorithm you're going to use, what architecture, how many layers that network is going to have, how many nodes, and so on. And that is just to make a test. And if it doesn't work, you have to reconfigure again with something else and make another test. And perhaps you get in that loop of trial and error until you get a result that is good. Now, since this training stage can take long, then we should have something to check whether what's the training status, and it's basically three. It could happen that the model is being trained, so we wait for a certain time. It may be that um, that it aborts, and we should be able to manage that error. If there is a happy ending, the model is no longer training and comes to status of ready, and there we can evaluate the model. I'll tell you how the arrows work, but then you evaluate the model, and in that case, you'll be able to obtain metrics on the basis of what you've generated so that you can decide whether that model is useful or not. Perhaps we could say how exact, how accurate it is, and that could be a merit. And we, as human beings, say, all right, this is convenient to apply that model and take it to production or not. And that's where we get to the next decision-making step. If we're not satisfied, we go back to the previous stages. Of course, the quality of the model would depend on the data that we provide and the configuration of AI. We don't have to worry about that because it's going to be capsuled in the train model that I'm going to present later on. And in happy ending would be where you would deploy that model. You make it available to be used. And lastly, the last stage, you already have the AI that is well trained, and then on the basis of new data, you'll be able to predict a personalized label that is something personalized according to your needs. You may retrain the model with new data, or you may even delete the model if you don't need it. And that's somehow the summary of a full flow of how you would train an AI model. You'll see that there are stages that are quite marked in the flow. As I said, training, status, evaluation, deploy, and also the question of deleting if you want it. Now, this can be done in GeneXusAI in two ways. You can use some cloud providers who offer a back office. You provide the training data, and you make training directly from there. For instance, this would be the back office for IBM. Here you have the images of butterflies and several options to be able to manage those data. Here you have the case of Microsoft, and here Google. And then on the other hand, you could use a new model, custom, it's called, and you'll be able to make training in GeneXus. And for that, there are several procedures offered that have exactly the same names we've seen in the flow chart that we've just seen in the previous transparency. This is the implementation status. This is for Google, SAP, Microsoft, and IBM. For those three, they are available in GeneXus 16. We are working to have these two providers available, and the others are in the research stage. We are thinking about introducing them. There is something else I haven't talked about, something which is predict, and that is on the basis of a new data value, we can make an inference, and that's predict. Now, let me tell you about the custom module so that it's clearer. How would we go about it? Well, the first step, as we showed in the flow diagram, you have to tag data. Suppose you have a pet, and you have a name, a photo of the pet, and a type of pet. And that pet type is going to be numbered, a dog, a cat, or a parrot. And so we go first through a stage of, let's imagine I'm a vet, and I start gathering data from my customers' pets, and I would have this transaction quite peopled to make a train and be able to infer the pet type on the basis of the photo I have. And that's quite a complete example. From the standpoint of GeneXus AI, we must create an object that generates data. What do I mean by this? Well, in this case, I decided to use a data provider whose output is data. Data is the type of data is going to be in the GeneXus AI module that has this type of structure where you will indicate the purpose of that data and an output data. So you have image in this case and the label that corresponds to it. In fact, what we're going to do is something like this. You'll have input, which is a pet photo that will go into a block, and that will be our entrance resource, and the output would be pet type as an attribute, which is the one we've seen before. So in that way, we'll be generating data. Now, what's the problem here? The problem is that this table could have many registers, perhaps too many, and the SDTs are all loaded in the memory. We could have a problem there. To avoid that, it's recommendable that you should put a PARM rule in order to page it. Now, the page it will be given by the number of pages and the size of page, and you can use the directives count and skip to page it. Now, count will tell us the number of elements on the page, and the skip is how many will be skipping. If page number is 1, and then so you would start counting from 0 to 10, because if the page number is 10, in the second iteration, this would go from 10 to 20, and so on and so forth. So that's the way we'll be paging the records that will be taken for training. And then the training stage. As I said, we're going to load data set type. We're going to load it in a variable. Well, the type is the name of the object. And then we're going to have a reference of the object in the call tree, because internally this is going to be a dynamic call to its object and a dynamic call so that you can start peopling the data. Now, we would call the train operation. We indicate a name and we say that the target with that objective is the label. I want to learn from the label of that data. Remember that we had a resource and then we got a label. We're going to give the name of this data generator, the provider, which is the one we've seen how you can you can load it, and then you're going to get some messages, information about the model. Then what we'll see is to check the state of that model. Once again, we call the primitive, we call check to the primitive. We have the data provider, we have the model data provider and the state. If the state is no longer training, then the loop is cut. Otherwise, it means that it's still being trained and we can wait for 60 seconds, for instance, and start checking again. We can wait more or less. And then finally, you can evaluate the model by calling the primitive of evaluate. And you can have a measure, and that is going to be another SDT that will have a main metric and a group of additional metrics so that you can choose whether you want to use another metric or not. But if the main metric we're considering, if the main metric is less than 0.8, then it's not worthwhile, and I run the model and forget about it. But if that's not the case, I would make a deploy, and then the model would be available. Now, let's update our providers, properties, or data. And to that end, we have a new key in the minion property key, which is going to we call model ID, and we're going to provide the information that has come back to us from which has been returned by the indicator. We have another one to indicate the version, which is also in the SDT model that has been returned by the previous operation. We can configure credentials in case the provider asks us to have different credentials to be used when making the prediction. And then we're going to use the model. Now, how do we use it? Well, we update the provider with the data of the model we want to use, and we call it classify. Then we have a new photograph of entrance. There was the provider loaded with the new information. And so if our entrance is something like this, then you take it to the GeneXus AI model, and it's going to tell us that the label is a dog and the label is a parrot with certain probabilities. And with these very simple steps, you have a model is just and personalized to be used. That is all. If you have any questions, I'm at your disposal. Cecilia will be giving you the mic and can go backwards if you're interested. And any questions? Yes. Hello. I'd like to ask you this. When you say that you delete the model, what is it that you delete? Is it the set of data that you are sending? Well, no, it's the instance. Let me explain it to you. The trained model has nothing to do with the model. You wouldn't have to regenerate it. They've already generated. What you'll delete, let me explain this to you. TensorFlow model is a small file that already has the data. So if you want to see it, you have to say that it has to model that it approaches a certain data. What you'll be deleting is the function, not the data. I'm not sure if I'm clear. It's not a function that you can have access to. In AI, functions are something that I learned. It's something that's learned, unlike what we are used to. We are the ones that create the functions to do something. But in AI, what you want is that AI to create that function to be used. Who creates it? Well, it's created by the train operation. When the model starts training, it starts adjusting that function until there is something somewhat correct to be used. What it does is to delete the neuronal network, not the data. Something that we haven't seen in any of the presentations is how do you record this? Because you've discussed this with providers and you may have some kind of agreement. But if I wanted to do it in my company, I would have to do what you've already done. So I don't know. I have to go into the program. Now, if I want to see something different in Google, I would have to register, or I don't know. How does it work? Well, you register in the platform of providers. In general, they all have a free trial per month, or you have some kind of trial for a certain time, and that's what you'll have to be able to make the comparison of what you want to do with providers. And you may even have a hybrid system if you use certain operations for a certain provider and other operations for others. Perhaps the latency is, it's a question of cost as well. But you basically register in each one of the platforms, and then you can have access for a trial period. And if I want to try three things at the same time, should I register? Yes, yes, you have. You have to. Hello. For facial recognition, I'm not sure if the image library and classify is working all right, because some time ago we did some research work, and we found out that Microsoft, there was an API that was very specific to do that, which is face. And I'm not sure if Classify is doing it all right with facial recognition. Your idea is to recognize faces of people in particular. Yes. Well, at present, I haven't mentioned this, but you've probably seen, let me go back here. When I train, when the target is labeled, there is another value that is going to work for Microsoft, which is region. Instead of a label, you can have region, and you can have a training model that detects a face and that also says who it is. Of course, you'll have to have the data beforehand, but you could probably use that model. If that doesn't work all right, the other possibility is to use the primitive of face tracer to give you the region where the image is and to train a personalized model to say who that person is in that rectangle. Is it clear? But is it working all right with Classify? Yes, it does. We haven't had problems. Well, we are just in 6, but I've tested it and it works quite all right. You have to have enough volume, not an exaggerated volume of data, but considerable volume. Well, I'm saying this because we had to do it from the outside to use an API of Microsoft, which is called Face, which is different from vision. Well, yes, but the purpose is the same. In this module, we're not dealing with API face precisely because we think that this other one is more flexible. Face is limited to one thing, and these are a bit more of a general purpose, and there may be a specific function of recognizing specific faces. Any other questions? What you said about face and vision, we suppose that face is a specialization of vision. If I use face, we are probably trained to look for noses and mouths and so on. You wanted something more subtle. It's not only detect faces, but detect contours. There are some things are not that clear about it, but you would have to see each solution in particular of each provider. But I can't tell you right now. I don't recall. I think I've read about those face API because what you are saying that would be good for our community. I mean, this has worked all right for this. I mean, as learning, you mean? Yes. So that you don't have to go along the same path you have already walked through. If you've already done it, I don't have to program things that you've already done. But then there is a learning period saying, well, if you want to recognize this, don't do it, don't do this, use this, use animal, which is good for butterflies or for whatever. And so if you want to recognize whales, well, that one won't be useful. And that recognition, I'm not sure if you're going to put it up in Wiki, but those are things that you're doing. Well, we're also experimenting. We are quite green in this yet, experimenting with different providers in different cases. We've got our own tests running, but they're quite basic. So I can tell you from that standpoint. I can't tell you from something taken up to production. Detecting things in movement. Have you got anything that's already been trained? For instance, if you wanted to use your mobile camera, is that the case? No. I mean, for instance, a car plate, let's say. Well, you have the OCR function, as I said earlier. Let me find it. There you go. I recall that. This is the OCR function. It's there, yes. That one will allow you to recognize car plates. You would have to do an additional work, but it's in movement. One thing is when the car is stopped, is not moving. The other thing when it's moving. Yes, as I said earlier, as it happens with the video module, a video is a sequence of images. Now, in that case, you would have to make your own previous processing to obtain different frames and perhaps value a certain sequence, three calls to this, and those three calls, it would you would see what the common factor is. Thank you.